All right, it's 7:05 now, so let's get started. Before that, so thanks everyone for joining us. Thanks for joining in a time of tight studying schedule. Hope you all are staying healthy and on track for upcoming final exams. I know there's another webinar just ended 20 minutes ago from the department, so I hope you all had a chance to grab some food. So logistic things first. This is the last IRisk Lab HackNack workshop for this semester. We will send out some surveys after the webinar. Please respond so that we can plan better for future semesters. And as usual, this webinar will be recorded and the slides will be shared later as well. So as the world outside gets more and more colorful, today we're going to cover some topics in data visualization. I'm very excited to introduce our speaker tonight. Matt Dzugan is a data science manager at Uptake. As you can read from his bio, Matt has a very strong technical background. He obtained both undergraduate and master degrees from Northwestern in one of the most challenging engineering subjects, electrical engineering, with specialization in wireless communication systems. He started his career at Boeing, working on satellite communication systems, and has won the Boeing World Class Engineer Award. Matt then joined Uptake as a data scientist, working on AI and IoT applications, specifically in the energy and utility space. He has made significant contributions in both modeling and product design, and won the Uptake Data Science Department MVP Award. Beyond all these achievements, Matt is also a highly skilled communicator. He can effectively present not only to technical audiences, such as data scientists and field engineers, but also to senior leaderships, educating customers on what AI is all about. So here I want to share a personal anecdote. When I first started the job, Matt assigned me a project to build an anomaly detection model of turbine power generation. So I worked hard for roughly 2 weeks, deriving various equations, testing hypotheses, and coding a package to implement my statistical model. When I confidently presented to Matt, he quickly drew a few charts and commented, so how about this type of signature? Which then led me to a few more iterations of improvements. So for a pure guy like me who studied theoretical mathematics back in school, this visual way of thinking was really eye-opening and feels like the dark side of the force. As Yoda once commented, if once you start down the dark path, forever will it dominate your destiny. So Matt, please take over from here and show us some secrets of your dark magic.
Wow, that was an incredible introduction. Thank you, Howard. Hopefully I can live up to that intro. So here, let me go in presentation mode here. I guess just before we kick off, just one last time, can someone, maybe Howard, can you confirm that you see the screen in full screen?
Yeah, it's perfect.
Okay, great. Okay, well, thanks everyone for joining. Like I kind of mentioned, for those of you who joined a little late, my plan is to take roughly an hour of your time. Could go a little short, a little long, we'll see. Great, so communicating data visually. Why did I called it this instead of just calling it data visualization? I think data visualization is a bit of a buzzword and something you can quickly Google and see books about, but I specifically wanted to title it communicating data visually because I really think that a lot of times the hardest part to get right about a data visualization is the communication piece. Sometimes it's easy to go in Excel and make a pie chart or a line graph, but just because you've put some colorful pixels on a page doesn't necessarily mean you've communicated a message. So I definitely wanted to draw attention to the communication aspect, and hopefully I've done that. So again, yep, my name is Matt Dzugan. Thanks for the intro, Hal. You can find me on the internets at these locations. But yeah, let's jump right into it. So I think I'm going to start off up front with just documenting what I hope you learn from this. Kind of want to just spill all the beans right away. If nothing else, to hopefully get your attention, or if you don't want to learn any of these things, then you can hop off and eat some dinner. So one of the things that I think is key, as I kind of touched about, is to be intentional about creating the scope of your visual. So we talked about communication. As you'll see in a second, I kind of view the communication domain as a spectrum that spans everywhere from exploring data to explaining data. Explaining being on one end of the spectrum with a specific purpose, and exploring sort of being more, you don't know what you're going to find, you can find tons of different pieces of information. So it's helpful to think of everything that you see in that world, and we'll do a little bit of that throughout the night. I'm also going to talk about tools, like software tools. You guys have probably used Excel. You've probably also used some specific actuarial tools that I'm not even familiar with. Maybe you've heard of things, programming languages like R and Python, or you've heard of Tableau. We'll touch on all that stuff. And in addition to the tools, we'll actually be talking about the people who use the tools, people on Twitter, various websites that you can check out, just to kind of see what's out there and help you learn and be inspired. And then we'll also talk through some very concrete do's and don'ts, like what's something you can walk away with and say, hey, I remember, in this talk, I learned that I should make a plot that looks like this, and I shouldn't make one that looks like this. So I figured, rather than doing a lot of philosophical talk, I might as well give you some concrete stuff as well. So one of the things I wanted to start with is why you should kind of listen to me. Why, as Howland said, I started in electrical engineering, and now I'm a data scientist. So why should you listen to me about data visualization? Well, I really like it. I love it, actually. And I think I've sort of thought about this. There's really three main reasons why I love it. One is because it's constantly a source of kind of math puzzles. So I just wrote one out here that I have kind of been thinking through recently. How can I lay out the 50 states in a way such that each state's area is proportional to its population while preserving the general layout of the states? So this is something you've probably even seen graphs like this. If you've, at the news, especially during the election cycle, they'll change the size of the states to kind of map to the size of the electoral college and things like that. That's an incredibly interesting problem. If you start to think about mathematically how you might, piece those puzzle pieces together while still keeping California on the left and keeping Florida on the bottom right, but, manipulating their size. That's a really fun puzzle. And that's one of the reasons I love about data visualization, is trying to solve stuff like that. Also, I think probably everyone on this call is going to end up in a technical field one day. And, sometimes technical fields, you can, as Howland kind of touched on, you can get buried deep in the weeds of making sure you have the best numerical answer. And you don't often have an escape to try something creative. So I think data visualization is a nice way to be a little creative every once in a while. And then thirdly, the most important reason, and the thing you're probably staring at because it's moving around on the page, is this GIF you see here is, I don't know, hopefully the GIF looks okay on Zoom. I know sometimes the streaming can be laggy. I tried to recreate the way that I read articles online. A lot of staring at pictures and not a lot of reading the words. I don't know if anyone else on the call is like me in that way, but that's kind of how I consume stuff. And I figured if that's how I consume stuff, there's probably others out there who consume stuff the same way. We might as well make stuff for that type of consumer. So that's just a little, hopefully give you a little flavor of myself and kind of why I'm here kind of blabbering at you guys. Okay, so with that being said, we'll kind of dive into our first section. So I'm calling it like the mental framework. Again, what's the sort of background ideas that you can keep in your head as you're building a data visualization? So again, I mentioned here, there's no right way to create a good data visualization, but these are a few things you can consider to kind of help you succeed down the road. Okay, so this is something that you'll see a lot of the practitioners of data visualization talk about, is that it's a spectrum. I kind of touched on it in the beginning too, but I'm going broader than data visualization. I'm going all the way as broad as data communication. So the most kind of generic way I can communicate data to someone is to just give them a file of data, just the raw data, pure numbers. Just dump an Excel sheet, no graphs, pure numbers, and I've communicated data. I've given them the true source of the data. The other side of the spectrum is what you might call the bottom line summary. So what's the sort of nugget of information? What's the meaningful insight, if you will, that's captured in that Excel sheet? So there's a couple ways we can think about this. one is not better than the other. They sort of offer different pros and cons. You know, the raw data takes little effort to prepare. Of course, a bottom line summary, you need to get the raw data and then transform it to find out the insight. So it's higher effort. In this case, the interpretation burden is on the audience when all you have are these little particles of data. Whereas here, the author sort of plays a role in the way that the data will be interpreted. But you know, a downside of that is if the author has any biases when they create the bottom line summary, their biases may be present. So let's get a little more concrete. What am I talking about? So you know, here's just one example off the top of my head. So a raw data communication might be, here are the results from XYZ model using the latest satellite measurements of air column. You know, maybe this guy's working in the weather industry. And then this guy just comes in and says, you will want to wear a sweater outside tomorrow. Again, I think it's both of those things are data communication, but it's just showing you the wide spectrum that this can take. And to kind of think about it, you know, we talked about biases. Biases can be present. Who says that this guy's threshold for wearing a sweater is the same as my threshold? I think that's an important thing. If I were hearing this guy talk, hey, you'll want to wear a sweater, I would immediately become skeptical. Like, well, how do you know? Why should I trust you? And that's a common thing to be wary of. The more you try to synthesize your data and the more you try to create a clear message, the more you're opening yourself up for people to be skeptical of you because they say, hey, what assumption did you make? How did you figure that out? Whereas if you're on this end of the spectrum, you're just showing pure facts. I think I even list that here. Yeah, pure facts without bias. So it's a spectrum. Again, there's no one right answer. But the thing I wanted to point out is that data visualization sort of spans almost the entire spectrum, with the sort of explore side on the left here near raw data and the explain side over on the right. So what I want to do to kind of put my money where my mouth is walk through a handful of examples that I pulled from the web, where we can see explore versus explain in action. I guess this is also a good time to point out, when I send these slides, I'm going to have a slide with a bunch of these references. So when you see a slide like this one, where I'm showing a graphic, I'll have all the links where I got this stuff from. Actually kind of ran out of time, and so I don't have it ready right now, but after this meeting, I'll be sure to send that out. Okay, so just to kind of lay the groundwork, I have 5 slides like this: explore, explain, explore, explain, explore. So let's dive into these ones. And again, it would be great if we were in person and we could do a little bit of interactive, you know, questions around the table. But like I said, I'll talk for a little while and then maybe I'll pause and take a break for questions. So this is a graphic that I absolutely love. I'm thinking this is more on the explore side. And again, I should point out, you know, none of this is official law. Is your graphic explore, explain? This is kind of my judgment of, you know, what I think this person's trying to do when they're creating this stuff. But, you know, you can imagine the graphic I'm about to show you here about energy is a little bit closer to the raw data. It doesn't have an opinion coming with it. It doesn't have any biases baked in. You can see, you know, 50 different states. You can see all of their energy production types. And then you can see how it tracks over time. So from 1990 to 2018, you know, there's many things you can take away. That's why I think this is more on the exploratory end. I can take away, like, wow, you know, these states on the West Coast have been doing renewable energy for a long time, and nobody in the South is doing renewable energy. Or I could say, you know, wow, Vermont had this incredible spike. Or I could say, well, when you look at things nationally, you know, Arkansas is kind of a microcosm of the national case. You know, there's a lot, or California is a microcosm of the national case, except for coal. Anyway, I'm just pointing out, like, there's so many different kind of, I call it over here, headlines that you could walk away with this. That it's kind of a good illustration of what it means to have like an exploratory data visualization. There's no one message of this. There's many messages, and I think that's pretty cool. let's go to the other side. What's something that explains? This is something from The Economist, where they're talking about how climbing Mount Everest is getting easier over time. So there's a lot of different pieces that make this up. But I think, one of the cool things is obviously there's a big eye candy with the map here, but then they show these really cool graphs here with the summit rate and the death rate. So of course they're showing the summit rate is increasing while the death rate is decreasing. And most importantly, the summit rate is increasing faster for Everest than for these other mountains. Again, each of these 5 little inset graphs are all in support of this bottom line thing that they want to explain, that Mount Everest is getting easier. So here's another Explore one. So how Trump compares with past presidents is, so this one's talking about approval rating. So for those of you who don't know, approval rating is it's actually a fairly standardized metric. There's a bunch of companies that go out and do polls of, humans just like us. Do you approve of the president? Yes or no? So, what's cool about this is they're actually plotting Trump's approval rating versus the other presidents in terms of like how many years since their first day in office. So you can sort of see, so like if I were to just look at Trump's, I might see like, okay, it dipped down a little bit and then it sort of flattened out. So one natural thing to wonder is like, well, is that initial dip, is that common for all the presidents? Well, it looks like for Reagan, that was definitely not the case. But for Clinton, Obama, Bush, that was the case. So again, just lots of different little nuggets you can take away out of this graphic. You could probably stare at this for quite a while and come out with lots of different takeaways. Okay, here's another one that I really like. Also, the most fun part of creating this presentation for you guys is just picking out all of my favorite, examples from the web and kind of curating them into one presentation. So I enjoyed that process. And hopefully, I'll inspire people with some pretty cool stuff here. So here's an explain one. And the thing that they're trying to explain is front and center right at the top. Urban and rural America are becoming increasingly polarized. So what they chose to do in order to illustrate that point is they chose to take a benchmark, 2004, and kind of show how things have changed, increasingly polarized. You can hear that the time domain is in that, in the headline. And so they want to show something changing over time. And so you can see here, these urban counties are tending more towards the left. That's the political left, right? Like more liberal. While the smaller counties over time are changing more towards the political right or more conservative. And you can even see they've got big fat numbers of how many counties are going which way. And you can sort of see it actually looks like these urban counties made the majority of the change between 2004 and 2008, whereas the smaller counties are making the majority of the change for Trump's election. So again, that's interesting thing to sort of observe from this. But again, this whole graphic is just all explaining this one bottom line. And I think if you go back to our explore versus explain, we talked about on the first example, how there's many different takeaways that you can get from this. There's really only one takeaway from this one, at least in my opinion. Maybe there's smaller supporting takeaways, but I think the main takeaway is exactly this. And then this is one of my all-time favorite ones. I'll just kind of read what I put on the side here. This graph is a good example of something that takes a bit of mental investment. It's not immediately obvious how to read it, but once you catch on, the number of conclusions you can reach is almost endless. This is one, again, I really like this one. So on the x-axis, it's showing the share of national wealth. So that is, for any one person's net worth, if you take the entire population of the US's net worth, what's one person's share of it? Or in this case, they're looking at what's one generation's share of it. And then what's the share of the population that is in that generation? So the way to sort of think about this is, you might think that if one generation, let's say Gen X or baby boomers, if that generation makes up 30% of the population, you might assume that they also hold 30% of the national wealth. Or similarly, if the population is only 10% millennials, maybe they have 10% of the national wealth. Well, what you can see in this graphic is that that is not at all the case. There's, like I said, there's many takeaways here. You can sort of see how millennials and Gen X's sort of compare to one another. They're very similar. The silent generation, that's the generation that came before the baby boomers. They have a completely different trajectory from anything else. In fact, so much so that in 1990, they had 80% of the national wealth, which is just kind of incredible. And let's see, what else? Well, I guess that's actually because it's multiple generations. They're saying silent and earlier. But again, many things to sort of pick out of this. You can even see there's so many dimensions. There's these two dimensions on the axis. There's a third dimension, which is which generation are you? There's a fourth dimension, which is which year is it? There's a fifth dimension, which is what age are the people, which I just think is super cool. And I think it's very well designed. And there's just so many things to pick out of it. You can see these little swirls that sort of happened in 2008, which is likely related to the economic recession that happened in the United States. Anyway, very cool. This is one of my favorite graphics. Yeah, I mentioned I could stare at this one for hours. Cool. So we talked about explore versus explain. We picked on 5 little cases. We want to touch on a common mistake that I see a lot. I've probably done it a number of times. And I think it's something hopefully all of you guys, as actuarial studies sort of future practitioners can keep in mind as well, which is a graphic used by an expert to explore their own data is pasted directly into a document to explain a concept to a less informed audience, right? So I've kind of made up 3 little examples here, again, using all stuff from around the web, where I've taken examples of people using a data visualization that's meaningful to them. They created it. They're very familiar with the nitty gritty of the data. They know what this chart means. This is one, hopefully Howen will like. We're looking at training an AI model, and we're looking at its loss over time. That's something that's very meaningful to the person creating this model. But if you show this to your boss and you say like, hey, here's how I know how my AI model is good enough to predict fraud on your bank account, they're going to look at this and have no idea why this shows that. This is something meant for one person to explore a concept on their own. It's not really meant to explain a concept to an audience, especially that's not familiar. Maybe doesn't have the jargon. Maybe doesn't have the background knowledge. And so that's something we'll talk about a little later as we talk about considerations for designing good data visualizations. We'll talk about considering your audience. But this is just starting to touch on that. So this is another one that I like. This is one that I found online. Someone was saying the housing market crash in 2008 should have been very clear if we were looking at the data. And then they presented this graphic. And I don't know about you, but I'm not a housing market expert, so I looked at this and I have no idea how I was supposed to know that the housing market is going to crash. So again, context is everything. The audience is everything. Understanding when you need to explore, when you need to explain. I think if there's one takeaway you get from this, hopefully it's that data visualization is not a one size fits all. You need to really consider what you're trying to do. So that being said, that's sort of the end of this section. Our next section is going to be design considerations. So, and again, I know we're on the Zoom sort of mode where I'm the only one who can talk. So I'll pause for a second and see. I think there's like a little raise hand feature. If anyone has any questions, maybe now would be a good time. Otherwise, I can kind of charge on. I'll pause for just a second to see if anyone has any questions they'd like to ask. Otherwise, we will move on. And again, we'll definitely pause at the end of everything for questions as well.
Hey Matt, maybe let me kickstart a question.
Sure.
Unless you're maybe a little bit shy right now.
Sure.
Okay. So you just presented quite a few wonderful visualizations. I'm wondering if you know any like disasters in mind that maybe drastically skewed the fact, or are maybe just like garbage data visualization.
Yeah, I do actually. I'll actually pull one up. Again, I don't want to get too too political, but it's an interesting case. Um, so there's I'll pull this one. I'll pull this up. I'm literally just Googling things right now, but I think it'll work. So let me share. There's actually a famous recent graphic, um, where, you know, Donald Trump, of course, getting pressured for being impeached. I think one of the things that he or someone on his team tweeted was this picture of the United States saying "impeach this," and the point of it is that, you know, what you're seeing is the messaging of this is meant to be like, hey, the entire country is all red. So red, for those who don't know, red is sort of the color that encodes the Republican Party, or, you know, Donald Trump in this case. Um, the message here is supposed to be like, look, the vast majority of the country voted red. How dare you think you could impeach me? Whereas, you know, in reality, we know that land area is not an important, or for that matter, in any way meaningful variable in terms of elections. It's all about people, right? And so, again, not to get too political, but what you really want to map is number of people or quantity of people. So a graphic like this that's meant to, it's a great question, Howard. It's meant to explain, you know, look, I have the backing of the entire country, but just showing a map of area, it doesn't accomplish that mission. It's explaining the wrong thing. So that would be my answer to that. That's a good question, Howard.
Great, thanks for that. So basically, my takeaway is that after I learned this webinar, I can start lying with data visualizations.
Yeah, in fact, there's a really good book that I'm going to have in one of my inspiration slides lower down. There's a book called How to Lie with Data Visualizations, and it's a, you know, tongue-in-cheek title meant to teach you how not to lie. But the point is, it's easy to lie with data visualizations. So you're right. Okay, let's get back into it. Cool. So design consideration. So here's the part where we'll get a little bit more technical, a little bit more, you know, actionable, if you will. Good visual communication is equal parts form and function. Without both, you either lose your audience's interest or you convey no information. So there's really two key guidelines that I want people to sort of walk away when thinking about data visualization. Create an effective graphic, create an appropriate message. So we sort of touched on the message stuff earlier, right? Who's the audience? What does the audience already know? What types of graphs does the audience typically view? What is the desired state of the audience? That's sort of another way of saying, like, are you trying to change their mind? Are you trying to re-convince them of something that they already know? Are you trying to, you know, reduce their skepticism? Are you trying to increase their skepticism? All of those things. And what sort of questions will your audience have? So, you know, that sort of gets back to one of the things we talked about earlier when we talked about the spectrum here of you know, communication. We talked about raw data versus bottom line summary. This guy who's saying you will want to wear a sweater outside tomorrow. Well, one question that the audience would have is, you know, what's your threshold for wearing a sweater? So it's something that seems simple, but you'll actually find that the more you do this, you can get really good at predicting the questions that people will ask. And I would say if there's one thing that you can sort of do when you're creating visuals, it's to really think about what your audience is going to ask, because the more, and that'll come with practice, the more you present, the more you deliver information, the better you'll get at sort of predicting what people are going to wonder about, predicting their questions. The better you can get at that, the more clear you can be, which is always the goal. And then create an effective graphic. So I've got a lot of slides that follow here about creating an effective graphic. So we'll kind of dive right into that. So whether whether this is something you've ever thought about or not, there's actually people, in universities around the globe who do research on data visualization. They actually do surveys, and it's kind of a marriage between computer science and psychology and sociology, and it's all meant to like figure out what do people do when they look at visual information. So one of the things that people do is they create these surveys where they'll take a data set and they visualize it different ways, maybe with a bar graph, maybe with a pie chart, maybe with some sort of color coded map or something like that. And they'll ask them questions like, what's the clear outlier from this graph, or which one of these elements is closest to the average, or which is closest to the median, or is something increasing or decreasing over time? And when you ask questions like that to enough people, you can start to get a feel for which way of displaying information are the most effective and which are least effective. And so what this one academic paper here did is they sort of ranked them all on a scale. They ranked them all on a scale, which is meta, because actually the position along a scale turns out is the most effective way to visualize information along an axis. So this graphic is following its own advice by placing these things along a scale. And so what you can see here are all the different things you might think of. You've probably seen plots that scale things by area, scale things by volume. That's much more rare. I really don't see these much. Curvature, honestly, I don't think I've ever seen something that tried to encode information and how much something is curved. But these ones you see all the time. How saturated a color is, or how much something is kind of black versus white. But yeah, I kind of wanted to draw your attention to these. This is, again, something to consider. Always good to think about. I think the bottom line takeaway is position on a scale is the most effective thing. That's why one of the things that you see as an extremely common plot type is a scatter plot. We'll see some scatter plots later, just showing a bunch of dots on an XY axis. Incredibly effective. Great. And so let's see a couple of these simultaneously put to use. That's the other kind of interesting thing. And we saw it here. Yeah. So here's, position along an axis. That sort of top feature there. But you can see here there's many things happening. Color is happening to encode different groups. Position along an axis. Whether it's intentional or not, the sort of angle and direction is also important too, right? Because the angle that you see here, they're specifically showing the arrows, because there's a difference between moving, down right and moving the other way. What it's saying about, a generation sort of trajectory is different and meaningfully different. Cool. So this is one of the most famous data visualizations ever. I think a lot of data viz nerds like to point to this as being, one of the sort of OG cool data viz examples, if you will. It's actually in French, so there's a kind of translated English version that I think we can look at, which is at least a little bit easier for me to understand. And so this is a really cool thing. It's showing actually the trajectory of the French army in this particular path through Russia in 1812. And so I think one of the things, and we can argue all the time about whether this is a good data visualization or bad. I would argue there's very rarely something that's good or bad. It's whether it communicates effectively. But I think the reason that people always like to call attention to this particular graphic is because it encodes many variables, right? So we talked about on the previous slide how you can encode a variable with position, you can encode something with color, you can encode with size. Well, this particular graphic kind of does all those at once. On one hand, it's an actual map. You can see rivers here, so in some way it's encoding location. It's also encoding the size of the army. I'm using my hands and my fingers to sort of describe. It's the width of this gray band showing the size of the army, and you can see there's these little call outs here. It starts with 400,000, men, and then, you know, whittles down to 100,000, but then they retreat and they come back, and you can see it's very striking to see like how much smaller the army has gotten. And, you know, then it's showing other things as well. It's showing the date, it's showing the temperature, as they walked across. It's showing, you know, it was a precipitation or not. So again, this is just kind of a fun little interesting example to kind of call out and show how you can do many of these things at once. This is definitely something I would call kind of exploratory, because there's so many different nuggets that you can piece out of it. But if you were going to argue that it's on the explanatory side, it's because one of the most striking things that you see is this big shaded area and just the size change of the army. And I think that's because, you know, area and the size of something is something that we're pretty good at picking out of a picture. Our eyes sort of will gravitate toward that shaded area, and it makes it very striking of how much smaller the army's gotten. So anyway, I just wanted to share that example, because if I was going to do a presentation on data visualization and I didn't show this, I would have my own, my own retreat that I would have to do. Okay, so let's speaking of kind of laying the groundwork and foundations for data visualization, there was sort of a transformative book that came out in 1983. I think one of the first sort of like well-received books on like how to do data viz stuff. So it's called The Visual Display of Quantitative Information. It's by this guy called Edward Tufte. I pulled out a couple quotes from the book that I thought are particularly interesting. Above all else, show the data, and a large share of ink on a graphic should present data information, the ink changing as the data change. Data ink is the non-erasable core of a graphic, the non-redundant ink arranged in response to variation in the numbers presented. So that's a lot of words. What he's really getting at, and what you'll see, is that this guy, Edward Tufte, is famous for kind of coining this term chart junk. He hates stuff that doesn't sort of contribute to the meaning of a graphic. So if we can go criticize some of these, you know, earlier plots here, like Edward Tufte would not like these gray lines that travel across. He would not like this border around here, because it's just ink that's wasted that doesn't communicate anything. Let's see if we can just pick out some other things. Even, you know, like these, let's see, like this little shaded stuff in between, all those things he would argue are just distractions from your core message. So again, he's sort of on one side of the spectrum, but it's useful to sort of see his opinion, which is sort of why I drew him here, as sort of rolling his eyes at all the visualizations that he sees of people not following his advice. And so now I'm going to blast into maybe 5 or 6 slides of super concrete do's and don'ts of creating data visualizations. These all come from a really great website that, again, I'll link as I send the slides later on tonight. You'll see it in the links, but it's actually created by some of the folks at Google, about like some do's and don'ts of data visualization. You know, talk about comparing pie charts is notoriously difficult to do. If you have to make a pie chart, you know, having one of them is maybe okay, but if you're comparing them, you're much better suited with a bar chart. You know, sometimes you need to have area as a representation in your plot. So a lot of times, you know, people will wonder, when is it best to just have a line versus an area? And you guys are all mathematics students. The way that I always think about this is probably the exact same way that will make sense in your brain. If it's something where taking the integral of it makes sense at all, then area is probably a meaningful representation for you. But if it's something that you're just plotting over time, maybe you can just get away with a line instead of an area. So for example, temperature over time, the sort of integral of that is not meaningful in any way. Like for one thing, like the zero temperature, depending on what you're doing, zero is kind of meaningless. So it just doesn't make sense to integrate that. Whereas, you know, in this little example, they're looking at users over the last 30 days. Well, integrating users over time would be sort of your cumulative user count that is meaningful. So that's a good time to use an area chart. So that's a little useful pro tip for you. Simpler design is better. You know, these little round things are just distracting. This is one of my favorite ones. The first time I sort of saw this tip, it changed me forever. Hopefully I can do the same for some of you. If you make a graph and you have 900 different colors like this, you're not helping anyone. No one can, you know, oh, what's the exact shade of blue that I have to, okay, it's the one that's blue, but it's a little bit green. Like, no one can do that. If you have a specific one to call out, make everything gray and, you know, highlight this one in purple or something like that. We'll actually see, as we explore some coronavirus visualizations at the end of the talk, we'll see a really, really, really good example of how you can marry these two together, where you want to show all 160 countries, but you don't want to have 160 different colors, because, you know, no one can do that. So there's a really kind of cool trick that we'll talk about in a little bit when we look at the coronavirus stuff. Cool. Again, there's multiple ways to encode your info, right? We talked about it up here. Whoops. Oh, I went way too far back. You know, these are all different ways to encode information. And so what this tip is trying to get at is you have all those at your disposal. You don't need to only use color. You can use like a dashed line, or change the texture of the line to sort of encode this month versus last month. You know, this is the cardinal sin of data visualization. Gets back to Howens. How do you lie with data visualizations? This is the easiest way to do it, is to take the zero off of your axis. If you're trying to show the number of positive comments and you want to make your boss think that you've made a huge change in positive comments, well, just take the zero off, because now it's going to look like they increased by tenfold. You know, going from here to here is an increase by like a factor of 10. That's what it looks like to my eyes, but you know, that's not the case. And so, of course, the data isn't really lying. If you read the chart carefully, you could know that this is 21% and this is 40, so they haven't even doubled. But you know, there's tons of research out there which shows that the way that we remember things is very much tied to like the visual. And so this is, like I said, this is the cardinal sin of data visualization. Please don't do this. If you take one thing away from this talk, it's this one. Always consider readability. You know, sometimes diagonal stuff is hard to read. And then this is one of my favorite ones from this web comic called XKCD. I'm sure a lot of you are familiar with it. If you're not familiar with this comic, it's very good. You know, I've linked it here. But if you're doing a map, make sure you consider the population. Like, I guess, you know, you can see this little corny cartoon here, but they're showing that you could come to the wrong conclusion if all you do is just show the number of something. Like, maybe I show the number of subscribers to Martha Stewart Living, and I might find out that, you know, they're all highly centered in these locations, and I might think like, oh, I got to really explore there. But really what you're just seeing is more people live there. So of course there's going to be more people in that location. So of course this is kind of a comical depiction, but the point is, transform your data. Do something per capita, or, you know, per unit area. In this case, you would want per capita. So again, that's just a nice pro tip for you. Like 9 times out of 10, if you're showing something on a map, you're going to want to see it per capita. And then we talked about, you know, considering your audience. So speaking of XKCD, you know, hopefully a lot of you guys are familiar with this comic. It's a really great comic for, you know, nerds like us. He did an interview with this website, the creator of XKCD, his name's Randall Monroe, did an interview with the website 538, which is something else that will come up later in our presentation. And he summarized this so well, and I highly recommend sort of everyone reading the whole article, if not even just this blurb. And I tend to not like reading straight off my slide, but I think that this is so important that I'm actually just going to read these 3 paragraphs. So one thing that bothers me is large numbers presented without context. We're always seeing things like, this canal project will require 1 million tons of concrete. It's presented as if that should mean something to us, as if numbers are inherently informative. So we feel like we don't understand it. It's our fault. But I have only a vague idea of what 1 ton of concrete looks like. I have no idea what to think of 1 million tons. Is that a lot? It's clearly supposed to sound like a lot because it has the word million in it. But on the other hand, The Adventures of Pluto Nash made 7 million at the box office, and it was one of the biggest flops in movie history. It can be more useful to look for context. Is concrete a surprisingly large share of the project's budget? Is the project going to consume more concrete than the rest of the state combined? Will the project use up a large share of the world's concrete? Or is this just easy space-filling trivia? And this is my favorite part. A good rule of thumb might be, if I add a 0 to this number, would the sentence containing it mean something different to me? If the answer is no, maybe the number has no business being in the sentence in the first place. So what he's trying to say here is if you multiply something by a factor of 10, so instead of 1 million tons, if it's 10 million tons, is that going to mean something different to you? For me personally, I don't know the difference between 1 million tons and 10 million tons. So that's a perfect example of what he's talking about, is that if you change something by a factor of 10 and nobody has any idea what that means, then you have to think of a different way to communicate it. And I think actually one of the graphics that we touched on earlier does a phenomenal job at this. Whoops. If all I showed you was Trump's approval rating, maybe Trump is a bad example because his is kind of the lowest, but if all I showed you was a single president's approval rating and said like, look at this, such and such president, Barack Obama is at 47.8% approval on day 1,195. Immediately, I would say, oh, okay, well, it's under half, so I suppose that's kind of bad. That's the first thing my head does, but I don't know if that's really that bad. It's only a little under half. Is that bad? And so it's something that this chart does a phenomenal job of. It immediately paints the context. Donald Trump is in green, and you can see every other president. That context is so important. So this is exactly what Randall Munroe is talking about, of making something have that context behind it. That's the most important thing you can do with a data visualization, right? Like I said, it's sort of in line with this. These people aren't sharing, these fictional cartoon people aren't sharing the context for why I should know that this orange line doing this means that my model is any good. So yeah, that's basically the design considerations section. So our next section is going to be on tools and software. So I guess before I go into the tools and software, maybe we can pause again. We're basically, just so people know, we're more than halfway through the slides. I know I said I would shoot for an hour, maybe targeting more like 90 minutes. We're more than halfway through, so thanks for bearing with me. Hope you've been learning something. Hope it's been interesting. But yeah, we can pause here for a minute if anyone has any questions.
Yeah, may I ask a question?
Yeah.
Hi, Matt. My name is Lisa. So can you go back to that slide where you showed like do and don't exactly when you skip the scale? No, the last one.
Oh, this one, yeah.
This one. So just personal example, what should I do if I have really like skewed distribution, for example, and I'm kind of forced not to start the vertical axis from 0, but from some other point? Should I like kind of play around with the scale? But yeah, so where is this like limits where I could lie to versus also to make sure that the plot in general is still readable and good looking and
yes,
and it refers the information?
Yeah, that's a really good question. So I'm gonna try to do two things at once. I'm gonna try to talk and pull up an example at the same time. So the first thing that I should say is, I say always include 0. Of course, if the number 0 isn't meaningful in any way, it's less important. It's less important to include it. So the example I always go to about what 0 being meaningful is, like, for example, in Fahrenheit temperature, the number 0 is not meaningful. So you shouldn't, you shouldn't take my advice in there. It's just most cases, if you're counting something, if you're checking the percent change in something, 9 times out of 10, 0 is a meaningful number. And so you'll know, when 0 is meaningful or not. But you're totally right. 0 could be meaningful, and you could have an incredibly skewed distribution. So I think there's a couple different ways to sort of handle it. One is to do like a little zoom out and zoom in version, which I see a lot. I think that's actually people's sort of best way to solve it. So I'm actually trying to pull up an example of that. If you'll give me just a moment, I can pull this up because I know I just saw it earlier today on Twitter, actually. And I know I can find it. There's a really good example. Perfect. I found it. Okay, let me share my screen with this. Can you see? I put up like a new graph. So yeah, I'm assuming
Matt, you are still presenting now. We can't really see that.
Sorry. Can you see it now? Now you can.
Yeah.
Yeah. Great. Okay. Thanks, Alan. This is sort of one method. So again, here's something coronavirus related. They're tracking deaths over time. So what's interesting here, maybe this problem is actually very similar to yours. So in this case, 0 deaths is incredibly meaningful. Like zero is a real thing. That's the goal, in fact, of course. So 0 is meaningful. You don't want to chop it off. So this example did what I would say is really the best case scenario. They sort of split halfway in between. So the main part of the graphic is like they put a lot of white space under it just to make sure you can still, you're still fairly zoomed in on where the action is, but there's plenty of white space here to sort of remind your eyeball that like, hey, there's still a lot of room under this graph. Of course, it doesn't go all the way to 0, but it goes a good portion of it. So that's the first trick, is to like not just zoom in. This graph could have really gone from 60,000 to 50,000. It would have looked completely different. So just this aesthetic of having all the white is like one good trick. And then what you notice here that they did in the lower right hand corner is they actually made like a little miniature version and saying like, here's what I zoomed into. So I think both of those tricks are good. There's another thing people will do from time to time where you've probably seen this before. You'll have a y-axis, and then they kind of like they use like a little squiggly line to kind of break up the y-axis. I don't know if I have an example of it here anywhere. It's going to take me longer to find it. But you probably know what I'm saying. They call it like, you can probably just Google. Let me try it. Broken axis graph. Yeah. Here's people doing that, but honestly, this is less good, because even though you're calling out the example that you're deleting space, it's still really hard for you to convince your eyeball. Like here, they're going from 0 to 1 to 7 million, then 32 million. It's hard to convince my eyes of like that this is really 5 times higher. So I would say that's not the best way. I would opt for something more like this. So hopefully that answers your question.
Yeah, great. I didn't know about this type of solution. Yeah, normally like you would break the axis, but indeed then graphs do not look that nice normally.
Yeah, exactly.
Great, thank you.
Yeah, no problem. Thanks for the question.
So Matt, I got a question.
Yeah.
You seem to keep mentioning context in your presentation. So because I understand your field is kind of technical, especially when you're talking about either satellites or like, I don't know, energy.
Sure.
How do you typically present context to a non-technical audience?
Yeah, so that's a really, really good question. That's, of course, one of the hardest things to do. And so I would say, hopefully the goal is that you don't have to sort of present the context itself. It's you sort of meet the audience halfway of understanding what is their context. And then you the presenter, you have what we call like the burden of proof, right? So if you're gonna convince the audience of something, you need to go with what their context is. This is obviously especially important, like if you're just doing something on the web, right? For the generic audience, if you're publishing something, you just have to assume that the generic audience person doesn't know the details of your study. So you have two options. You either present something in exactly the language that they understand and using the exact sort of facts that they understand, or you kind of have to show that context to them to kind of meet them somewhere in the middle. So I think the best way to do that is, like, if you have to share something incredibly technical to someone who there's no chance they're gonna understand the technical bit, right? So let's say I have to, I'm just making this up, I have to explain how much energy my wind farm is going to generate to someone who they know nothing. All they are, it's Warren Buffett. So he's an investor in many energy companies. He knows about, he's kind of interested in the energy sector, but he doesn't know, does the average wind farm make a gigawatt or a megawatt or a terawatt? He would have no idea, right? It's the Randall Monroe. Like if you added a zero, he would have no concept of that. So I think the best bet is to just compare to other things, right? Compare to different wind farms. Show your example compared to many other examples, or show your example today compared to your example over time, right? There's usually some point you're trying to make. Are you trying to say ours is the best? In which case, take yours and show it to all the other ones around it and show why your bar is higher than all those other bars. Or are you trying to say that yours is increasing the fastest? In that case, show the slope of your thing and then show it to all the other slopes and show why yours is the best. So I think, again, there's no one size fits all answer to your question, but I would say most often the best way to give context is to show other data. And so it may not be that people understand is 1,000 users a lot or is 250 users a lot, and they may not have that exact background, but if you can show them like, here's all the other websites that are out there, and then here's our website, well, then suddenly it becomes a little bit more useful. So does that help a little bit?
Well, that kind of helps. Then how do you make sure that your comparison is not like biased, or do you typically just find some other examples to make your point?
Yeah, no, and that's that's how you can lie. Again, that's a fallacy that we call cherry picking, right? So I could certainly, when people use the phrase cherry picking, they usually mean like you picked an example to help prove your case. And so that again goes back to this guy, and why we might always be skeptical of this guy who just says to go wear a sweater. If I say, hey, my website's better than the other ones, then people are going to naturally ask questions. Well, why did you pick those websites? And again, there's no answer to your question. I guess I would just say, like, the best thing you can do is think about what does your generic audience consider to be the baseline? Like, what are their expectations? What's the status quo for them? And another thing I want to point out is if you are trying to, share data that spans like a y-axis like this, and your website is truly so much better than all the others that it would blow all the other ones off the axis, there's still ways you can normalize against that, right? Do something per capita or do percent change. There's always ways that you can take things that maybe are different on the surface, but then you can make them all the same if you represent them in terms of percent or in terms of percent the time since they've been opened. In fact, I'll spill the beans real quick and go to one of my favorite coronavirus plots, because this one does, I think, a phenomenal job of doing the exact thing you're asking about. Mm-hmm. All these different countries are different, right? They're all experiencing something different. They're all experiencing the pandemic in different ways. You might say, how can it even be meaningful at all to put them on the same axis? And we can argue about whether this plot is even valid because all the countries are doing testing in different ways. All that is true. But there's one thing that this chart does, which I think answers your question. It's days since average daily deaths past 3. So before this guy is the first guy who did this. Before he was doing this, everyone was just showing, January 1st, March 1st, April 1st as the x-axis, but that tells a different story and makes it harder to compare. As soon as people started saying like, okay, wait, let's make the sort of zero mark, the starter point, be the time at which the pandemic sort of reached a certain state, and then we compare from there. Again, that's a sort of long-winded way of me answering your question, but I'm just saying there's always tricks you can pull out of your sleeve to make things that are different sort of seem the same, or at least make not seem the same, but make them appropriate for comparison.
Got it. So some sort of normalization.
Totally. I think normalization would be your key word for sure.
Got it. Thank you very much, Matt. It's been very helpful.
No problem. This is great. I'm glad, despite us being virtual, that we can have question and answer. Okay, I'm going to go on to the next section just for time's sake, because I do want to kind of get to the point where we can finish, and then those who have questions can kind of hang around after. So let's talk about tools. If you're interested in data visualization, one of the things that I'm going to do soon is I'll be sharing a list of people that I recommend you follow on Twitter. Whenever those people post something really cool, inevitably there's people in the comments that say like, oh, what tool did you use to make that? How'd you do that? Oh, like, is that using this? Is that using that? Like, what library did you use for that? So it's clear that thinking about tools is at the forefront of people's minds. So I wanted to make sure I touched on tools. So what I've done is I've created what I'm calling like the landscape of tools. I created a data visualization out of data visualization tools. And the two axes that I've chosen to display is like how flexible it is. So what I mean by that is like, can you make anything you can dream of? And then how friendly is it to learn? So there's things out there that are hard to learn. There's things out there that are easy to learn. So a couple kind of anchor points of this visualization that I'll call out are pencil and paper. Right away, it's highly flexible. You can make anything with pencil and paper, and it's very beginner friendly. So that's sort of what I mean by this. Excel also pretty beginner friendly, but you can't make everything. If you wanted to have a map that looks a certain way and it's viewed from this angle and it's high, you can't really do that. On the flip side, there's something called D3, which is a JavaScript library, which is incredibly flexible. In fact, that's what, if you see something on the New York Times, Washington Post, any of those like big news organizations, that's how they make everything. But it's really hard to learn, right? If it can build all those whiz-bang interactive stuff, it's going to be tricky to learn. So I wanted to sort of share this. This is one dude's opinion. There's certainly no metrics on these that I can use to quantitatively place them on this axis. This is my opinion. I'm also noticing that my little legend, I lost the legend. I'll fix that when I send out the slides. But the one with the green lines through it means something. The green line means it requires programming, computer programming. So, I'm aware that, some of you guys are, trying to learn a little bit about programming. Others, have less programming skills. Certainly not required for data visualization, but, there are ways where you can imagine programming and data visualization combining. And so these ones that I've sort of highlighted in green are sort of ones that you approach from more of a coding side. It's also important to point out, like, I've just plotted two axes here. There's other axes, like, can it make an interactive thing, or can it handle gigabytes worth of data? Those are also important to think about when you're thinking about tools. But I don't want to stay on this slide too long, because I don't want this to be the focus of my presentation. And the reason why is because of this. If you use Tableau, it can make incredibly awesome things, but it can also make garbage. And if you use D3, it can make awesome maps, but it can also make garbage. And even in Excel, you can make like really pretty useful dashboards, but it can also make garbage. And so I wanted to point that out because, and I kind of use a little analogy here, a shiny new pair of basketball shoes isn't going to make me as good as Michael Jordan. And also Michael Jordan could beat me even if he was wearing ski boots. Like, the tools are useful, but it's not gonna make or break an effective visualization. They're really just tools. What you need is to have the idea and execute on the idea. The tools will certainly help you execute on the idea, but there's nothing inherent in making a chart in Excel that guarantees it's going to do a good job of communicating your message. So for that reason, my tools and software section only has 2 slides. This is all I want to talk about tools, because while I think it's useful to kind of introduce you guys to the tools and sort of introduce you guys to thinking of them in terms of the sort of spectrum here, I don't want to take away of the presentation to be like, oh, I must learn Tableau or I must learn D3, because that's simply not true. Great. So let's talk about learning by example. So they say imitation is the best form of flattery, but turns out it's also just a really good way to get good ideas and like practice data visualization. So the slides that follow, I have, let's see, 1, 2, 3, 4, 5 slides after this. Kind of broken it up into people to follow on Twitter, big newspapers, smaller websites, Reddit, which is awesome. For those of you who are unfamiliar with Reddit, highly recommend. It does take a little bit to figure out how to use Reddit. I will admit it's not the most intuitive website, but once you figure it out, lots of really good stuff in there. There's this thing called the Data Visualization Society. So let's talk about these. So Twitter is by far my favorite way to kind of get cool data viz and get cool content. Like you saw even earlier in the slide, someone asked a question and I was like, oh, I remember I saw that on Twitter earlier today, and was able to pull it up. So I've picked here 20 or so lists of people to follow. Certainly this is not the definitive one list, but if you follow these 20 people, you're going to get some really cool stuff. And then you'll see them retweet others and you'll be entered into that whole universe. So this should certainly get you started. I've shown a couple things here that just highlight a couple of the people's work that I've seen recently. Of course on Twitter too, they support GIFs. So there's tons of really cool animated stuff like this one. So if you're interested in this stuff, there's just so much cool eye candy, insert the heart eyes emoji for sure. So again, there's not really much for me to present here. This is more meant to be a reference for you guys. So hopefully when I send these over, you can go have a Twitter spree. Newspapers. So these are the big newspapers that, in my opinion, are doing the best data visualization work. Washington Post, New York Times, The Economist. Again, they're doing like really incredible stuff. In fact, a lot of these folks that you see on Twitter either are currently working or previously worked at one of these big publications, because it's a really good way. If you're good at making this stuff, it's a good way to make a living. Niche publications. So these are like smaller sites. You guys may be familiar with 538. That's maybe a bigger one. They recently bought out by ESPN/Disney, so they're a little bit bigger now. But it's kind of run by famous, I guess, data scientist or analyst Nate Silver. So that's his company. They do really cool stuff, especially around the elections. There's this other website called Flowing Data, which is basically a blog. It's fantastic. Highly recommend checking it out. There's this website called distill.pub. This is so cool if you guys are interested in AI at all. Basically what they are is they're kind of like a journal. You can think of them as an academic journal, except in order to be accepted by them, you need to have just phenomenal visualizations. And they actually work with you. They're almost like a consulting firm. They like help you create awesome stuff. So there's really cool stuff there. The content of the journal, if you will, is mostly centered around AI machine learning stuff. But just like honestly, go to that website, pick a few articles and scroll through them. It's so cool. And then there's this other website which is really like the cream of the crop across the industry, or I shouldn't say industry. Data visualization isn't really an industry. The field which is called pudding.cool. This is one of their examples that they do, which I think like it blew my mind when I first saw this. You know, as a data scientist, I'm always thinking of what's the way I can take many metrics and turn it into one metric, right? Like if I have all these different things and I want to say the bottom line number, you know, the overall index is X, like how can I take a weighted average of all my different metrics to sort of create the best metric? Well, they have this one particular graphic in here where they actually let you slide around a slider knob of how you want to weight these two metrics, in this case, quality versus quantity. And then as you reweight the two metrics, you can see how they've like visually interpreted that as a scatter plot that's actually getting rotated in the 2D Cartesian plane, such that the one that's closest to the top of the graph is the best in your new weighted metric, which is something that's like so cool. I never thought about how when you take a weighted sum of many metrics, you're actually just doing like a linear algebra transformation, and you could interpret that visually. It seems so obvious in hindsight, but these guys were the first ones that I've ever seen kind of do that linear algebra representation where you say, okay, I've got quality versus quantity. Now let's actually plot the weighted average changing, and the one that's near the top of the graph is the new best in that metric. I thought that blew my mind. That's like the one thing for nerds like you guys, I think that's the one reason to go check these guys out, because that is just so cool. And then there's Reddit. So of course, Reddit is built of multiple what they call subreddits, which are basically just little topics. So the topic you want here is data is beautiful. They do a contest every month where they actually post a data set, and then everyone has to make a submission for that given data set. In this case, I've just picked a couple cool examples. Again, I'll post the links to these. This guy is, you know, rating many different TV shows. He's showing their ratings change over time. This is a person who let their bike, they pushed a bike 800 times without a person on it, and then they kind of mapped the trajectory. It's pretty cool. This is someone mapping the sleep cycle of their baby for the first year of the baby's life. Blue is asleep and orange is awake. You can sort of see the sort of trends emerge. Again, pretty cool stuff. Then there's what they call the Data Visualization Society. This is a website. You can go join it right now. Just Google search it, and you can join this society. Basically, what it means when you join it is you get access to a Slack group. So it's basically just a message board, a forum of people who are trying to make cool stuff, trying to make visualization. So really good place to just go and find other people who are trying to do stuff. So a good example of what you'd find in that community is when I finish this slides, I'm going to post these slides over there in case anyone can find them helpful. They also have what they call a publication. So it's, if you're familiar with the website Medium, they basically are a host for blogs. They have a Medium blog called Nightingale where they post lots of really, really cool stuff, really high quality. Highly recommended if you're interested in this sort of thing. So again, hopefully that's some good sources of inspiration for everyone. And with that being said, the next section will be the last section where we'll talk through some COVID-19 visualizations. And one thing that I really want to point out is something really interesting. Actually, in the Slack group for the Data Visualization Society, there's been a lot of talk as to whether or not people who are just good at visualization have any right to be posting graphics of coronavirus stuff, because this is obviously such a serious topic. If maybe I'm great at data visualization, but I don't have that context that we talked about earlier, I don't have that sort of true background expertise of epidemiology, is it really right for me to create visualizations? And the consensus among the community is actually like, no. People who are data scientists and data visualization practitioners, even though you might just really want to get your hands on that data and make something, it's kind of irresponsible. So I present that as a word of, not a word of caution, but just, again, useful context of something to consider. Like if you're going to share something on Twitter that you made and you don't know anything about viruses, and it suddenly 100,000 people see it, you've kind of opened up a can of worms. So you got to make sure that your messaging is clear. So let's talk through one. I just love showing this one because this is something that was in the White House prep briefings, and it's easy to pick on, but like what is this even trying to show? I guess each one of these states is a different color. I couldn't tell you which two of these states are. I guess this one's New York, probably. But like, what's the orange one? Is it, I don't know, this orange, New Jersey? Is it this orange? I literally don't know the answer. Or is it two? Is it Washington and another one? I don't know. Anyway, this one's easy to critique, right? It kind of falls into a couple traps that we've talked about earlier. It falls into the trap of doing the color thing. It falls into the trap of, let's see, well, at least their y-axis is 0. But I think what we're going to talk about in the next few slides are another couple much better examples. So this one's really cool. This is actually a photograph of the New York Times, the newspaper. If you're like me, you probably just think of the New York Times as a website now, but it's good to remember that it's an actual piece of paper. So this is a really cool photograph of the April 8th front page. I think it's really cool. Again, the messaging, there's so many design decisions that you could make. Like, if someone said, hey, you have so many pixels to fill up a graphic, go ahead and do it. They would have to rescale that y-axis, and then New York would be down here, and then all the other cities would be much lower. Someone made the idea, no, I want New York to fly off the page, and I want it to shoot all the way up there, which again, it makes a statement. So again, that's why you have to be super careful. Even the color choice of red, it definitely makes a statement. It evokes some emotion, that's for sure. This is one that's on the CDC's website, Center for Disease Control. So again, this is a government website. I don't know, kind of interesting. They use a technique which is sort of debated in the community on when do you use categories of data versus just having a continuous scale. Certainly 25,000 or more makes me wonder, okay, so there's many states in that category. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 states that are in this bucket. So should I be mentally treating them all the same? Is Louisiana the same as Michigan? Is Michigan the same as Connecticut? Is it the same as California? I literally don't know. I'm pretty sure that New York has like 5 times as many as California. So that's a little bit misleading from this graph. Again, all just going back to different design decisions. Then we get to the one that I already sort of spoiled as my favorite. I think this is the most successful visualization of some of the coronavirus data. I won't harp on it too long, but there's just so many things that are done right. We talked about the normalization on the x-axis of kind of starting everyone at the same point. You do notice there is a log scale here used, which again is highly debated in the community. People are debating if the lay audience is smart enough to interpret the log scale. So again, you can maybe decide on your own if you agree or disagree with that. But in this case, it definitely helps kind of contain everything. A couple other things, you can see color is sort of used to clump countries together. So again, I'm not relying on color because all the countries are labeled here. It's not like I've got 20 different colors and then a legend off the side, which is mapping the color to the legend. It's all done right on the graph, which is really nice. It makes it really easy to see. What else do I want to point out about this one? And then look, there's also just some other countries that aren't even labeled, which is fine. And the reason why that's fine is because what accompanies this graph is this graph, which is, I think, phenomenal. So this one gets at the solution to this, which we saw earlier. So I would say, 9 times out of 10, if you have all these different things and you're trying to show them all, you probably have a message. Maybe you do really care about, your website, or you do really care about the United States, and that's the core one you want to focus on. Just color that one different and make everything else gray. But in the cases where you really are trying to focus on, hundreds of different things at once, way more than you have different colors, like, this is a great approach. It shows everything else. And if you want to have certain reference points, you can see they're even highlighting China, Italy, and a couple of the different graphs. So then your eye can sort of visually sort of connect the dots. Anyway, I think this is just so good. There's so much you can learn from just this graph. I really like it. Again, this is all from the same website. In fact, the same guy, this John Murdoch, who's one of the guys I tell you to follow on Twitter. Really good. He starts to talk more about how you can know, how you can sort of compare case counts. So, people are saying all the countries are having different testing methodologies. Well, one of the things that you can do is, in a relative sense, you can start to look at, has the number of deaths in the hospital increased over time? So yeah, maybe we can't get an absolute sense because the testing methodology is different. But here, if we use percentage change, and we map it, relative to an initial starting point, well, then you can sort of see the different phases that the different countries are in, which I think is cool. And then there's this, which I think is awesome, because people started wondering, okay, well, what if we're just like missing a bunch of the deaths? People are dying. It's through whatever accounting error. It's not being captured as a death related to coronavirus. Well, then one thing you can do is you can just say, well, let's just take the data for all deaths, all reasons for death, any reason for death, and plot it. And so what you see here is 1970 through 2019. So you're establishing this sort of norm of, for each week of the year, how many deaths do we typically expect to see of all causes, right? Any cause of death. So there's both old age, heart attack, whatever, automobile accident, it's all rolled into this. And then, so the cool thing is they're showing each year as a point. So your brain can sort of establish this band of normality, sort of anomaly detection, if you will. If you built an anomaly detection algorithm, you would see that this is a clear anomaly, right? This how 2020 is. The number of deaths overall, something roughly 12,000 or so is probably what we should be on track for. And so then that delta, you can clearly see visually, is due to coronavirus. And so then again, you can do a similar thing with multiple countries, and you can really see the picture of the effect on multiple countries. So again, I think these are some really good examples. Any of these ones that are from this Financial Times website from this guy, John Murdoch, are super good. I think he's doing a phenomenal, responsible job of presenting this data. And so with that, that's all I have. So that gets me to an hour and a half. Thanks everyone for sticking around. I have nowhere to go. So of course I'm staying home just like you all are. So if anyone has questions, I'll be around. I guess I should have also put my email address on here if anyone wants to contact me offline. If you go to my mattdzugan.com, my email address you'll be able to find it there. So sorry for not making it more clear, or you can message me on Twitter, however you feel the best way to reach out to me, please do it. Hopefully from the existing Q&A that we did, you've gathered that, I'm an open book and willing to help answer questions. So with that being said, let's take any other questions. Anything else I can answer? Anyone want to chat about anything? Otherwise, that's all I have.
Okay, thank you very much for your presentation, Matt. So it's a question that I kind of like to ask a lot of data scientists, but how did you get crawling into the dark side at first? How did you start learning all these fancy visualization gizmos?
Yeah, that's a really good question. So actually, the way I first, I'll go a little bit off script here, and actually start Googling some things live, so bear with me. But the way I first got into it was in a sort of roundabout way. So there's this website called, or not website, there's this tool called Processing. It's a little bit out of date. It's kind of from the early 2000s. It's basically a way to like make visuals. And so what I first saw is there's this guy online. This guy is so awesome. He just makes these really cool, like, I don't know how to explain it. Hopefully these GIFs are like coming across, just this incredible eye candy. And he makes all these in processing. And I was like mesmerized by this stuff that this guy makes. He's been doing it for years. It's so good. And so I sort of was like, wow, I want to be able to do that. I want to be able to use code to make stuff. And so that was my initial sort of I guess how I caught the bug, is I was just like so enamored with this stuff that this guy does, is I was like, I have to figure out how to just make stuff with code. Like I need to, and this was before I knew how to do any programming. So I was like, I need to learn how to program. I need to learn how to do code so that I can do this stuff. So that was my sort of initial spark of inspiration, I guess you can say. And where I went from there is, you know, as kind of Howen said in the intro, I'm an incredibly like technical person, like engineering degrees. I'm a data scientist now. So it wouldn't be enough for me, for my own personal satisfaction, to just be sort of an artist like this guy. I want to have a technical profession. So what I found is that like data visualization is a super good way to sort of combine this like awesome, just make cool stuff with technical skills. And so, to be honest, the first way was after I kind of learned processing. I was like, okay, well, how do the people who make super good data visualizations do it? So, like I said, those big news articles and all those things I shared, they're all using this thing called D3. So I was like, okay, well, the next thing I got to do is I got to learn this. I got to learn D3. And so at the time, this was, probably like 2000. It was like 10 years ago now, like 2010. So at the time, the creator of D3 was posting. Let me show you this. And he's another guy that I mentioned to follow on Twitter. He's the guy who created this visualization library, and for every he was constantly just showing like, hey, I made this cool thing using D3. It's an abstract version of Starry Night, and then he always showed the code. And so every single one of these things on his page, I just like, I don't know, I read them until I understood it. It's maybe not the best way to learn programming. Maybe a better way is to read a book. But he just showed all this stuff, and I was like, I just read it all, and that's how I sort of learned D3. And so that's maybe a long-winded way of answering your question, but I would say like a lot of other things in life, if you can find how other people are doing something and you want to mimic them, that's sometimes the best inspiration you can have. And then what my next suggestion would be is like literally just pick a project, pick something, pick anything. It could be like the project I sort of used to make myself learn D3 even more was like, I had this question of, here, I'll show you on my website. I had this question of like, if you're ever driving along the highway and you noticed, like if you're literally on, I-55, or what is it that goes down to U of I? Is it 65? I can't remember. If you're on the highway driving and you see those signs, they say like towards St. Louis, like take this towards St. Louis, or take this towards Chicago. I just like had this question. I was like, how do they determine which city goes on that side? Like, could you build an algorithm to kind of like decide that. So I chose that as my question, and I just scraped some data off the internet, and I just figured I wanted to make like some visualizations that say like, let's see, 65, is this the one that goes to Urbana, Memphis?
57.
Anyway, it's 57.
Mhm.
Yeah, we should see. Oh, there you go, Champaign. So here's the duration of 57 in yellow, and for this segment of the highway, you can see all the times where it's pointing to Champaign. So looks like honestly for a good like half of the highway, the signs are saying to go to Champaign. So I just like pick, it could be the stupidest thing like this. This is clearly not useful for anything. It's just a stupid topic, but I just decided that I want to do that, and I wanted to make visualizations. I wanted to make maps. So here, let's see if we do Champaign on here. Yeah, so I can zoom in on here and see all of the segments of highways that the signs say are going to Champaign. And as you can see, there's a big hole right here where Champaign is, which makes sense. Anyway, that's a really long answer to your question. I would say pick someone you want to emulate online, and then just pick a question and just make stuff. That's the best. Step 1, be inspired. Step 2, pick a stupid project and just do it. That's the best advice I can have.
Got it.
Good question.
Do it.
Just do it. and it will be bad. It will be bad before it's good, and that's okay.
Hey, Matt, we'll have a question in the chat.
Oh, I haven't been looking at the chat. How do I see the chat? Oh, okay. Hold on. I'm looking at the chat now. Okay. How would you improve any of the graphs shown at a common mistake slide? Aha. That's a really good. So there's a couple questions in here. So I don't know if you guys have all figured out how to view the chat. So I'm just going to go through these questions in order. So the first one is around the common mistake slide. Okay. So the first question is, how would you improve any of the graphs shown at a common mistake slide? Any concrete suggestions? So yes. So what I would say, and this is sort of a softball answer, maybe you guys won't like my answer, but it's the true answer, is it's to really go back and think about what we talked about on this slide, which is, think about what you're trying to do. Who is the audience? What does the audience know? What types of graphs do they view? What's the desired state? Really, what's the message that you're trying to convey? And the reason why I say to think about those things is because I think oftentimes it's not even just about fixing these graphs. These are literally the wrong graphs to show. And so that's why I wanted to title my talk, communicating data visually. I'm not just talking about how to make a good graph. 9 times out of 10, what's more important in making a good graph is picking which is the good graph to show, right? Or which is the right data to visualize. So I realize that's a bit of a hand-wavy answer. It's not super satisfying, but like for this one, my advice, like I can give a concrete advice for this one. Maybe this is a data scientist. They're building a really good AI model. Whoops. They're building a good AI model. They can see here that the model is like starting to converge and it's like doing a really good job. Okay, so this is how the data scientist knows that the model is starting to do a good job. That's great. This is a meaningful visualization for them. This is like technical jargon, if you will. It's like, it's useful for them. But let's take a step back. So what did it show? It showed this person that the model is doing a good job. So let's take a step back. Now I want to make a data viz from scratch, and I want it to answer the question, is my model doing a good job? So just take a step back and think about that. Is my model doing a good job? Okay, how can I answer that question? All right, well, the way to answer the question, is my model doing a good job? Well, what's the job my model's trying to do? It's trying to predict fraud. So maybe what I can do is I can like simulate some data where I can create, a million different cases of fraud, and I see, is the model able to detect them? So then maybe all I have to show is I have to show like my model is able to detect 90% of the cases of fraud, and here's what the 10% of cases that it's not detecting look like. Again, it's showing a different graph. So, it's not necessarily about just, using better colors to make this graph better. So it's oftentimes about showing different information. So that would be my answer to that. Okay. Hey, Matt, how do you normally present context? I think that one was answered verbally, so I will skip that one for now. And then Howen says, okay, to ask your question. Good. Okay, what are some interesting books that you would like to suggest? Okay, that's great. Yeah, that's a good point. In my inspiration section, I did not talk about books. So let me, just as a note to self, I'm gonna make a blank slide here called books. And I will, like I said, you guys will be getting a copy of these slides after the presentation, but a few that come to mind: How to Lie with Charts by Alberto Cairo. I might have the title slightly wrong. Data points, whoops. Ethan, yeah. And then I forget the title, but it's something with D3, and it's by Elijah Meeks. So I will, sorry, kind of caught me on the spot there, but I'll follow up. I'll complete this slide, and I will send that list to everyone. So great question. These first two books are fantastic. I've read them both, and this book came out after I learned D3. I wish I would have had it when I was around, but I've thumbed through some of it, and I know people who read it, and it's really good. And the author of it is someone I really respect, so I'm sure it's very good if you want to learn D3. This one is about, again, D3 is that tool that I mentioned. That's the sort of high learning curve. Oops, where was that slide? Here. This one, the one that can do almost everything, but it's kind of tricky to learn. So that's a phenomenal book. Those cartoon figures are cute. Yeah, thank you. I stumbled across those. It's one of those things where the internet is awesome. There's a person who has open sourced, totally license free. You don't even need to contribute back or anything. Although now I'm giving them a pretty good shout out. It actually allows you to customize these little figures. It's it's really cool. So I came across this, and I was like, I gotta put this in the presentation. So Matt, thank you.
Your screen.
I'm sorry about that. Thank you. Sorry. Yeah, this library here called Open Peeps. Anyway, just some cool designer out on the internet was feeling generous and made this open source, and so you could create your little people as you saw me do throughout the presentation. So I'm glad you guys liked it. Okay, so that's all the questions in the chat. So if anyone has any other questions, feel free to either ask them verbally, or if you want to ask them in the chat, do that. I'm paying attention in both places.
Sure, I guess I got another question.
Sure.
So how do you typically start off doing exploratory data analysis with visualization?
That's a good question. So I use tools that are familiar and comfortable to me. So let's go back to the spectrum. So myself, I do know how to program, fortunately. So or I shouldn't say fortunately, but I've made that investment. So there's a programming language called R, which maybe some of you are familiar with. I think it has decent overlap with the actuarial community. Case in point being Howen. And so there's a library there called ggplot2, which is phenomenal. It's something that, again, it requires a little bit of effort to learn it, but once you've kind of understood it, it's sort of a way of thinking. In fact, the GG stands for grammar of graphics. So it's sort of built off the idea that if you can think of graphics in a certain way, almost like words form a grammar in a sentence, there's components of a chart that form a plot. If you can think in that way, then it's really easy to create these graphics. So that's basically what I do. It's become second nature to me. I can like do it really quickly, but it's still, there's a question buried within your question, is like, how do you know which stuff to plot when you're exploring data? And so I think that's something that's a super good question, and it's something that you get better at over time the more you've kind of practiced. But what I would say is, before you open up your data set and before you build any graphs, the best thing, the best advice I have is, and I have it, it's in our presentation, is what questions will your audience have? So in case of exploratory data analysis, you are the audience. I'm making a graph so that I can learn what's in my data. I'm trying to figure out what the data looks like. So I'm the audience. And so before I build anything, I want to know what questions will the audience have. So maybe I wonder, what's the age distribution of people? Or is age distribution related to likelihood of smoking? Or, is the state that I live in correlated to like, there's so many questions that I might have that I literally would advise people to just write them down in your text editor or whatever, and figure out how to make graphs that answer that question. That'll get you two things. That will remove your bias that inevitably will come from already seeing the data. Because once you see the data, you're tainted by like, oh, I noticed that there's this number in here. I want to explore that. So come up with some questions at first. And then it's also good practice of something that you have to be good at anyway, which is taking a question and figuring out a way to answer it visually. So that would be my advice for you, is just figure out like, what are the questions that you have before diving in, and just like really come up with a good list of questions. It can be like 10 questions, and it's okay to make 20 graphs to answer those 10 questions. It's really good practice. And to my honest opinion is that that's much more fruitful than finding some application that someone on the web has built that says, dump your data in here and it'll automatically create 500 different graphs of a histogram and a scatter. Like, yeah, that stuff is useful sometimes, but for yourself to have that introspective moment of asking yourself what you're trying to do and then forcing yourself to actually build graphs to answer those questions, that's much better, in my opinion.
Right, so it's practice.
Yeah, yeah. Practice. But the thing that you should practice is like taking a moment before you open the data and just like ask yourself questions. And of course, I say before I open the data, maybe you need to know some basic things, like you need to know what columns are there and you need to know a little bit about the context. But once you have that, you should be able to ask yourself some stuff. And that's where I would start. And then inevitably, like, let me see if I can find a good example here. Because once you start that, like here, let's just pick I'm just going off the cuff, picking an example. Like maybe I ask like, okay, I want to see Donald Trump's approval ratings compared to all prior presidents. That's a question that I think it's conceivable that you wouldn't even need the data. You could be smart enough to ask yourself that before you open the data. So let's say you're thinking ahead, you say, I want to see Trump compared to all the other presidents. And so then you see this and you say like, wow, okay, now I see this. Then it becomes this recursive structure where you see this and now you have more questions. You're like, oh wow, what happened to Bush at the end of his first year? Well, I think, again, spoiler alert, it's September 11th, exactly. But you might have other things like, okay, what happened? Why did Reagan have this? Or like, okay, is there a pattern between Republicans and Democrats? Or like, is there a pattern? They all seem to go down. Like once you do one thing, it sort of introduces these other questions. And again, like I said, the skill is having a question and figuring out how to create the visual to answer it. In fact, one of the people that I recommended you follow on Twitter, this guy, this is that Nathan Yao. His sort of slogan is like, I forget how he says it exactly, but it's something along the lines of like, ask a question, build a graph that answers the question. Like that's his 2-step thing. And so maybe I'm just parroting him, but I believe in that very firmly. So yeah.
All right.
Thank you. Great question.
Thank
Lots
you,
of
Matt.
really good questions, guys. I appreciate it.
Hey Matt, thanks for the phenomenal presentation. I want to follow up on that from Titan, the undeclared identifier guy. So
Screw you. Never mind.
unfortunately, I identified you. So yeah, so follow up on discussion that picking a project, iterate and practice. I'm wondering, what's sort of the minimum viable skill set that's needed or required, to get started. Before data visualization, obviously data must exist first. So someone have to know some way to first get data and then play with data, wrangling data and plotting data, and then being able to find help if they get stuck. I think these are all, skills needed, but what's sort of the minimum or roughly the minimum viable skill sets that one should learn before they can get started? And once they get started, obviously, learning path is state dependent. So once they get started, what's a recommended trajectory to improve themselves?
Yeah, that's a really good question, Howen. So I'm gonna answer it in a couple different parts. So what's the minimum required kind of entry point that you mentioned? I think the minimum entry point is to be able to use any of the tools that I mentioned on the tool slide, which, let's keep in mind, also includes pencil and paper. So if you can do that, you have the minimum required skills. And like you said, another minimum requirement is that there must be data. So that's what I would offer. Again, I linked everyone in the presentation to the subreddit for data visualization called Data is Beautiful. And I mentioned how there's a monthly contest. And so the cool thing about these monthly contests is, so let's see if we can find the previous content, or the previous contest, I should say. I want to see. So again, like I mentioned, Reddit is a little bit hard to use. But basically what they do is they post a data set and then they ask people to do visualizations for the data set. So let me just show you one that I actually participated in, because I know how to find the link. Again, I'm not super good at using Reddit. So let's find this. Okay, so here was a battle for, or they call it a battle, for August 2018, visualized TSA claims. So basically, there's a data set. The data set for this month is TSA claims. And so you can go to that website and then, like, literally right here, here's the data. And so the reason why I bring this up, Howland, is it's a good place to have data, and it's a good place to just see, whoops, gotta click this. It's a good place to just see, like, how are other people doing things. So these are all, the different people, everyone's submitting their stuff, everyone's looks different. It's a really good way to see the sort of diversity that comes from different people's answers. And everyone's usually pretty good about posting how they do it. And the reason why I bring that up is, like, let's just look at this person's. Okay, this person's using Tableau. Like, wow, looks pretty cool. Here's another person did one in Tableau. Looks totally different, but still pretty cool. Let's find another one. So the reason I bring this up, like, here, is this one gonna be a map or something? Yeah, okay, cool. Anyway, like, the reason I bring this up is it's a good way to sort of have like a community around it. You can see people are giving each other like positive feedback. It's really nice. And I wanted to bring up, a lot of people do this in Excel, and I've even seen entries where people submit their entries in pencil and paper. So it's a really cool place to, like, sort of get that sort of practice. And if it's also competitive. So if you do want to be the best, it might sort of, inspire you to get better and try to learn new skills. So I think that answers. Did your question? I feel like there was another part near the end of your question that I didn't quite answer.
Yeah, so the follow up part of this is that after I get started learning from others and maybe also iterate on my own submission or my own practice, if I get stuck or if I get
Oh
confused,
yeah.
where can I find help?
Yeah, that's good. So I would say two places, and um, they're both kind of just what I've seen. So on Twitter, basically, if the people who use hashtag DataViz or any of those people who I listed, they're all usually really helpful. If you have a coding question, you can post questions on GitHub or something like that. But I would say the best way is actually to join that thing that I called the Data Visualization Society. So let me go back and show that slide. Because if you join the Data Viz Society, you get access to what I call their Slack group. So Slack, for those of you who don't know, it's kind of just like a instant messenger / forum / message board. And so there's specific channels within Slack that are devoted towards like newbie questions, or not even newbie questions, but I need help using this tool, or I need help. They even have a section called there's a specific channel called critique. So let's say you build something and you think it's pretty good, you can like open up and say like, hey, I made this, it's a starting point, give me some feedback. And then there's usually like 10 people will go and give you feedback on your work. It's really positive vibes community. It's really nice. So that would be another recommendation, is within that Data Viz Society and joining their Slack group.
Awesome, that's great. I guess another follow up on that. So I think you mentioned at the beginning you were just getting interested in the tools, in the visualizations that people make, and then you started learning it yourself. I'm wondering how that experience sort of feedback in your work, and how that helped either your previous role, current role, or how that helped you pivot to maybe other careers or other type of focus.
Really good question, Helen, as usual. So I would I would say I would say, and you kind of touched on it too, actually, in your intro, Helen, is that the communication is a really good skill, especially for those of us in technical fields, like probably everyone on this call. Um, I think the ability to communicate is probably the one thing that you don't really learn in school. Maybe at U of I know at Northwestern they made us take one public speaking course to get our engineering degree, but it didn't really have the vibe of like learning how to communicate your ideas in a professional setting. I think the better you can do that, the more doors you unlock, whether it's communicating to your boss. Howard and I work together, and one of the things that we always talk about is how the work that you can do, even if you're doing the best work and you build the best model, or you create the best analysis or the best code, it's only as good as people know how good it is, right? So if you make something and it has a great impact on some customer's bottom line, it's only good if people truly understand that it's having that effect on the bottom line. And oftentimes it's up to you, the employee, to kind of illustrate that effect. So you have to be your own advocate in communicating how good or bad some of your work is. And so I think the better you can be at sort of concisely communicating, like, hey, I spent the last 2 months working on this, and boom, here's what it does for you. That's just a really good, useful skill that I think anyone can benefit from.
Great, awesome. Okay, I don't see further questions in the chat.
I have a quick question.
Sure.
So I really enjoyed your presentation, and especially slides. I guess my question is less on data visualization and more on the presentation design. Do you have any tips or tools you use when creating these slides? For example, I really enjoyed how you use that green to highlight certain things. I guess how do you choose like fonts, and is there a tool you use to find a nice color, or do you just kind of have a good eye for that?
Well, first of all, that's a very nice compliment, so thank you. That's a really good question. Definitely a small part of it is a skill that you mentioned, like you said, I have a good eye for it. I think that is a small part of it, that comes over time. I'm not going to kind of overstep that. I've noticed, like, in myself, when I review some of the stuff, like how instead I was at Boeing, and before that obviously was getting my master's at Northwestern. Like, I review stuff that I made back then, and I'm like, ooh, like current me would not make that. So I do think that there's a piece that grows over time, but I think the majority of it is actually can be taught and can be learned very quickly. It's a couple rules of thumb. So one thing that I try to do is, like, just be super judicious with color. Color is an extremely, like, think of color as like fire, right? Like, it's really useful, but if there's too much of it, it's really bad. I think, again, I sort of alluded to it earlier. Like, when I first saw this technique in data viz, it blew my mind, and it everything became so obvious of, like, everything I had ever done wrong in the past when I saw this technique. And I think it's applicable everywhere. Like, honestly, most information can be conveyed in black and white. In fact, I was actually, the Data Visualization Society, they do these little things called fireside chats, where they'll host Zoom calls much like this, and people pick each other's brains. And so there was one a couple weeks ago about how to use color. And one of the kind of resounding things that came out of that talk was people talked about, they made it into a rhyme, but now I can't remember how it rhymes. It was like, first get it right in black and white, then something color. I don't know. I can't make it rhyme, but the point is, do stuff in black and white and then, like, add color. You shouldn't be using color to, like, to sort of be a critical part of your presentation. Also, not to mention, 10% of men have some form of color blindness. So 10% of men, and I think like 2% of women. So roughly 5% of the population has color blindness. So it's another thing to consider. But to answer your question, that's one of my main rules of thumb, is like to be super judicious with color and to really, like, hold back. Like I mentioned, I'm like a 3-year-old when I consume media. Like, if something's moving and bright and flashy, I'm always going to look at it. And so I'm very aware of that when you see a slide that has a bazillion colors on it, it's, like, very distracting. So I think that's one tool. The other rule of thumb is, there's this notion in graphic design that they call like visual hierarchy. So visual hierarchy is, like, really easy to understand. I'm not a graphic designer. I don't claim to be, but the concepts are useful. Like, visual hierarchy is just, like, what's the importance of the stuff? Like, how thick and meaningful is the content? So, like, here, this title, it just feels huge. And then, like, here, this is, like, it's almost like if you squint your eyes, right? Like, if you squint your eyes, this seems really big and dark, and this is really, really shaded and light. So the rule of thumb that I'm getting at is, you should think of making a visual hierarchy that matches the information hierarchy. So you should, if something is, like, really important, make it really big and really bold and really black. Like, I don't know why the max size in PowerPoint goes up to, like, 60. Like, here, I'm using font 88. Why the heck not? It's big. It looks cool. So that's what I do. Like, I think it's okay to do that. So hopefully that answers your question. To summarize, I know I rambled a lot. I tend to ramble a lot. The two things would be, use color very sparingly and intentionally. And then the second thing would be, figure out a visual hierarchy. That's something you can Google, by the way, visual hierarchy, look it up. And figure out how to make a visual hierarchy that matches your sort of information hierarchy. Like, how important is your content? Those would be my tips.
Gotcha, thank you so much. And I think going off of a tip you mentioned in your slide about learning from example, thank you for this great presentation to learn from.
Oh, thanks. Well, the one thing I haven't figured out yet is, I just looked at my computer. It's like 400 megabytes, so I'm not quite sure why that is. So I'm gonna have to figure that out before I send it along. But thank you for the compliment.
Hey, Matt, I kind of want to follow up on that. So you mentioned, learning from example and learning from other people. I think another aspect of learning that's more efficient is like learning from a template or learning from a textbook type of thing. I think you have a few references I will point out. I'm just wondering, say if I'm coding, I can plagiarize on GitHub right away. I'm wondering if there's any sort of GitHub-like or template-like sources or repos for data visualization or making presentation that I would recommend.
That's a good question. So, what I would say, so I totally agree with you. What I would say, so here's my initial gut answer to that. So let me go back to what I said. So there's this website that will be in my reference, which, like I mentioned, I sort of ran out of time for, but I will send you guys my reference list. Okay, I realize I'm not sharing my screen, so let me share this website. Okay, there's this cool website here. The reason I'm sharing this is they talk like types of charts, change over time. You pretty much got these options. Category comparison, you pretty much got these options. Ranking something, parts of a whole, correlation, distribution. The reason I'm showing this is to point out, aside from some like super wild, novel, really creative stuff that's almost closer to art, there's generally like a finite amount of types of plots there can be. Like when you really think about it, we talked about these different mechanisms on my, switch back to the slides. We talked about, where's my slides? Wait, PowerPoint? Oh, yeah, we talked about these different mechanisms. There's really only a finite amount of ways you can combine these things to create a plot. So it makes sense that there's a finite amount of plot types. So the reason I bring that up is a lot of these different tools will have the majority of those plot types as sort of like templated options for you. So like, for example, if you highlight a couple, cells of data in Excel, it's already going to recommend to you like, try this plot type or this. So I would say that half of my answer to you, Helen, is that a lot of these tools sort of come with that idea of templates sort of built into them. But the other thing I would say is that some of the tools don't. Like D3, for example, it doesn't. For those of you who are curious, when you're building something in D3, it's very akin to, how you might draw something. You say, okay, I want to put a rectangle here. I want to put a circle here. I want to put the letter X here. Like you're building it up from scratch. It doesn't know anything about a scatter plot. It doesn't even know anything about an axis. You have to say, draw a line and draw an arrow. So that's why D3 is harder to learn, but it's also so flexible. So it doesn't know anything about a scatter plot. So my other thing to point out to you, Helen, would be that, there are people who build other libraries on top of something like D3 to help act as templates. But even then, it's not super strict and rigorous. So I would say, yeah, there's templates out there baked into some of these tools. But for those of you who don't want to be constricted by the templates, there's sort of other tools that don't have the templates. And so that's a meaningful difference that you could imagine across these different tools. And so to answer your question, yeah, I think that answers your question. You also mentioned like templates for presentations like this. Again, I would just say pick someone who you think did it well and copy off them. That's my best suggestion.
Yes, stand on the shoulder of giants.
There you go. Exactly.
Science, right?
Exactly. Yeah, I really cannot recommend enough. Like hopefully you guys walk away from this presentation with a couple things, a couple pro tips like we did in these slides. But like, if nothing else, man, like seriously, just take an hour out of your day, like really an hour, and just sit down and just look up all this stuff. Like it's so cool. If you're really interested in this, these people are phenomenal, and there's just so much good stuff out there. It will, and again, it's the more you see it, the more you understand how to be good at it, the more you look at the really good ones, the easier it is. Like just look at how cool this is. It's so easy to find like what the message is, what's the point. It's going to make it so obvious to you that when you see something like this, that it's like, okay, that's maybe not a really good one. And so it's just something that comes with practice over time. And so I would really recommend kind of diving into these different publications, because it's really good stuff here. And I owe you guys the books, so I will send that.
That's awesome. Thank you.
Yeah. Cool.
Right.
Well, I think that maybe wraps it up.
Yeah. Any last minute questions, comments?
I just want to say that this has been a phenomenal presentation. The graphics were just too good.
Oh, thank you. Well, like Howard said, I stand on the shoulders of giants. So hopefully I've, like, a lot of people's first foray into this stuff is because they highlight data in Excel and they see that a bar chart is an option. So if there's one thing, hopefully you walk away with this realizing that it's a whole big world out there and it's tons of fun. So hopefully I've inspired a few of you guys.
Great, you definitely did.
Good.
Really hope to keep in touch with you.
Yeah, like I said, Twitter, email, whatever. I'm an open book. I tend to be one of those people who gives out their contact info to too many people, and then I, I'm happy to help everyone. So please take advantage.
Thank you very much, Matt. Appreciate it.
And also, just by the way, Matt just had a LinkedIn account as well.
Yes, I recently built LinkedIn. For a while, I was skeptical of the value of LinkedIn, but I finally made one. So I'm on there too. So you can connect with me or whatever it's called.
All right, great. Let me just wrap things up. And while I'm talking, Matt, you can maybe think of a few sentences of concluding remarks, like the final takeaways.
Sure.
Yeah. So today, we covered a lot. We talked about communicating data, the spectrum of data communication, different design frameworks or philosophies, tools for doing that, and also a lot more examples and references for you to learn from. And again, I think this presentation is worth reviewing and worth coming back. It's really like an iterative learning process, and the learning really happens. Learning really don't happen until you start practicing. And then after you get some experience, you can come back and then review, and hopefully you'll learn more from it. Yeah, so with that, Matt, do you have any last minute, any comment, any final takeaways?
Not really. Maybe we'll just make a full sandwich out of it and kind of review where we started. So again, just really, I really hope now if you take the explain versus explore thing with you and like take a critical eye to everything you see and be like, is this person trying to explore or explain? Or even if you're making something, are you trying to explore or explain? And really think of the sort of ramifications that has on what you're doing. Again, definitely check out the list of tools and the sort of people I suggest to follow, the websites I suggest to follow. And if nothing else, hopefully you walk away with a couple tips of design help. So it's been fun for me. Like I kind of mentioned at the beginning, I had a bunch of this content kind of scattered around, so it's been fun for me to kind of collapse it all to this presentation. You guys have been great, really fantastic questions. Thanks for sticking around. It's been let's see, 135 minutes. So I appreciate taking that much of all your time. Yeah, thanks again.
Awesome, great. Thank you, Matt. So with that, we'll conclude this semester's of webinar. Good luck on final exams.